This is video 15.5. Today we're going to be talking about isomers. This is a term that you need to make sure that you star and that you are super familiar with. There will be at least one question dealing with isomers on your test. Okay, and this is a topic that I really want to stress and take some time with this year, whereas last year we didn't spend as much time and it showed up on the test. Okay, so really commit this term. If this is one of the only things that you remember from organic, this is a big one, okay? It's a big ticket item that you should definitely make sure that you remember. So isomers, guys, they are compounds that have the same molecular formula but have different structural formulas which then result in different names. Okay, so they have the same number of carbon atoms, same number of hydrogens, but the way that their structures are built leads to them having different names and ultimately different structures. They have different chemical and physical properties, something else that you want to keep track of and remember. Okay, different chemical and physical properties. At least 4 carbons must be present in a molecule to have potential isomers. So kind of going along with that, something to keep in mind, methane, ethane, and propane do not have any isomers. There's no other possible way to draw methane, ethane, or propane. Okay, so we can see here from all the practice hopefully that you've done, this would be methane because it's 1 carbon, and then over here would be propane because you've got the 3. Okay, butane is the first molecule to have isomers. The larger the molecule, the more isomers that you can have. Okay, so keep that in mind as well. There are 3 ways that you can make an isomer. You can make a branch. So you may have had a straight chain alkane or alkene or alkyne. Well, we could kind of maybe move it around to make a branch come off one of the carbons. We could move a branch. So if there is already a branch that is present in the molecule, you could move it from one carbon to another. Or you can also move a multiple bond. So what I mean by multiple bonds means that it could be a double or triple bond and just move it from 2 carbons to 2 different carbons. Okay, so that's kind of the big thing. So make sure you really take some time to practice, because your quiz that you can start taking next week, you've got to be able to not only name compounds, but make sure you can be able to draw isomers. So the biggest thing, guys, you've got to have a visual mind, okay? So those of you who are creative, this may come easier than those who are analytical. I know this is something that I struggle with, trying to picture in my mind kind of what's going on. So the best way to kind of start thinking about isomers is to draw whatever compound they say, hey, draw isomers of this compound. We'll start with that compound because that is one of the isomers. So example 1 right here, pentane, okay? Pentane has 5 carbons, so we would draw the normal structure like this, right? Straight chained, all the carbons nice in a nice row, all the different hydrogens all around it, right? So pentane C5H12 based on our formula for alkanes, right? So noticing, hey, that suffix there is ane, so we know it's all single bonds. So what we could do then with our structure of pentane is we could start to move things around, right? We could either make a branch. Notice how there are no branches currently in this pentane molecule. So if we go and look over here at this second one, what we've done is we've taken maybe this end carbon and we've just moved it to this guy, okay? We've moved it so that now our long chain has 1, 2, 3, 4 carbons in it, all right? But then we have this branch. So now, instead of having pentane, we get 2-methylbutane. Same number. Notice, count up your carbons. So there's 5 carbons, so that would be C5, all right? And then if I count up my hydrogens, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oops, that's 11 comes after 10, and 12. It's still H12. They still have the exact same number of atoms, it's just their position has changed, okay? And that leads to them having a different name, all right? A different name. 1, 2, 3, 4. That's where we get the butane part, because our prefix for 4 is but. and then we get 2-methyl. Well, I didn't label my carbons correctly. 1, 2, 3, 4, because remember, any branches, guys, they need to be on the lowest numbered carbon. So that's where we get 2-methyl butane. So we did, in this case, with this one, we made a branch. Okay, it's not the only thing we could have done. All right, for pentane, there's another possible piece that we could have done, and that's this guy here. We could have made 2 branches. So we could have moved not only this guy on the end, we could have also moved the other end guy onto that middle carbon as well. And that's what they've done in this example. 1, 2, 3. So we have our main chain is 3 carbons. Again, we could even go this way, okay, where it's like this. We could go like this. That's still 3. Any way that you draw a line to connect the longest chain, it's 3, whether it's this way as well or this way across. So that's where we get the 1, 2, 3, where, hey, 3, right, our prefix is prop. So that's 3. Then we would start to worry about the chains. So I've got 1 carbon hanging off of this guy, and I've got 1 carbon on the other side of this guy. So that's where I get the 2,2, because they're both on carbon 2, dimethyl propane. Okay, so we not only made 1 branch, we made 2. So you could do any of these 3 possibilities. You can kind of get creative. The biggest thing, guys, is you just got to make sure that it's different than something you've already drawn. Okay, and that's where it can get a little confusing, because again, how you label those carbons. Like I messed up here on this one originally in the middle. If I might think, oh well, if I label it 1, 2, 3, 4, that could be different. That's 3-methyl butane. Well, guys, that doesn't make sense, right? Because the methyl has to be on the lowest numbered carbon. It's the same structure, even though I named it different. I named it incorrectly, thinking that, hey, maybe it was something different, but it was actually the same. Okay, so keep track as well, guys. You can only make branches on non-terminal carbons. What do I mean by non-terminal, guys? Terminal means end, right? So you have to move branches to the inside carbons, okay? So really, you can only make it on the inside carbons. That's what non-terminal means, inside. Okay, terminal would be end, so these non-terminals would be inside carbons, so you got to move it. So that's kind of the first place I would start, is try to make branches coming off of those inside carbons. This is going to take some skill, guys, to kind of do it, but again, start with your formula, okay? Isomers have to have the same number of carbons and the same number of hydrogens, they're just in a different position. Okay, so it's going to take some practice. Make sure you take an entire day to practice, and then also with that practice of drawing isomers, naming, right? So that's a way you can practice more naming with the alkanes, alkenes, and alkynes. So let's take a look. Okay, we're going to draw pentane isomers. So we're either going to break off a terminal carbon and put it on a non-terminal one, or move the double bond around. So pentane, guys, start there. What's my prefix, right? Pent, so that means I'm going to have C5. Now, ene. What class of compound is that? That's an alkene. So if you look on table Q, our formula for alkenes are CnH2n. Okay? CnH2n. So to figure out your number of hydrogens, we're just going to double the number of carbons. So in this case, it's C5H10. Okay, so start with that structure first, the straight chain version of it. So 1, 2, 3, 4, 5. All right, then fill in. Notice it's pentene. Okay, pentene. If there's no number associated there, guys, you can assume it's the double bond is going to be on the first carbon, whether you start from the left side or the right side. Okay, whichever way you want to name it. This is the same structure as this. Okay, those both are the same structures. So now fill in your hydrogens. 1, 2, 3, 4, 5, 6, 7. Now, how many will this guy get right here? Think, he's already got 1, 2, 3 bonds, so he's only going to get 1 hydrogen, and this guy needs 2. Okay, so if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 1 isomer of pentene. So that's a good first place to start. Okay. All right, so now you got to come up with 4 more. Okay, there's 4 more isomers that we could have for pentene. Okay, so the first place that I would personally start is you could start with branches. All right, so we could move that around. So let's keep our double bond in the same spot. So there's my first spot. Okay, now think. I'm going to do this in a different color to kind of show this. I've got to take a terminal carbon and I've got to place it on an inside one. Now, if I go here, did I really change the position? No, just because I moved it up to the top, it's still going to be 5 in a row. Okay, so I need to move it to an inside carbon. So that's going to be my first one that I'm going to do, is I'm going to emulate that. So I'm going to have 4 carbons in my main line now, and I'm going to move this other terminal carbon to the third guy. And I'm going to fill in all my hydrogens to make sure that I have the correct number. This guy needs 1, and then this guy would need 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Still have 10 hydrogens. Right? So that's one isomer. Same number of carbons. This is still C5H10. Okay, but now the name would be different. I encourage you guys to pause it really quickly and try to name this compound. So now if I'm going to name this, all right, I've got my main chain is 4, so it's going to end in butene, okay, because I've got a double bond. It's an alkene. And then this would be 1, 2, 3, 4 carbons. Why? Because if it's not specified, okay, it's going to be that the double bond is on the first carbon, so this would be 3-methyl-butene. 3-methyl-butene. So that's, I'm sorry, I didn't mean to erase that. So that would be one isomer. Okay. Well, let's go back to my original structure again. Okay, do something with a different color. So let's move that terminal, this guy, well, let's move him down here to this other inside one. Okay, so if we remove that end chain, guys, we really only have, the opportunity for a couple of different branches. So same thing, it's going to be 4 carbons. My double bond stayed where it was, but now I've got my methyl coming off this guy. So I'm going to fill in my hydrogens. Okay, it would look something like that. Count them up. I still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, still H10 and C5. How would we name this guy? Well, it's going to be butene because my long chain is 4, right? And now this is going to be 2-methylbutene, okay? Because the carbon methyl chain moved from the carbon 3 to carbon 2. Now, another way that we could do this is instead of moving carbons around to make branches, we can also move this bond around, okay? I could move this bond over one. So let's do that. Still going to be 5 carbons in my long chain, but all I've done is move the double bond. So it's going to shift things around a little bit. But notice, still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, so it's still H10, and it's C5. Notice my long chain is 5 carbons long. All right? So it's still going to be pentene, but now, instead of just pentene where it'd be like 1 pentene, this is going to be 2 pentene because that's where my double bond is. It's on carbon number 2. Okay? Now, if you're thinking about this is where you need to get creative. Kind of, look at all your different possibilities. We might think, well, I could just move this here. Guys, if I move this double bond there, is that really any different than this structure that we just did, this 2-pentene? No, it's the same structure because now instead of labeling 1, 2, 3, 4, 5 carbons, okay, we'd have to label it this way, and it's still 2-pentene. We'd switch it around, remember, because the double bond, the carbon numbering system that we use is still that the double bond is in the lowest number of possible carbon. All right, so let me go back and refix that. All right. So the other possible way that you could do this, guys, is to flip this around and make this an aromatic. So we could close this structure. And this is where things get a little bit interesting. Okay? Would I anticipate you guys seeing something like this on your reagents? No. But it kind of makes a pentagon type structure. And then you can just put your double bond in anywhere and then fill in with hydrogens all around. Okay, 1, 2, 3, 4, 5, 6, 7, 8. No, I'm sorry. That doesn't make any sense. Because you wouldn't have enough hydrogens. All right. So, pause the video, come up with the other one. I need to go back and check myself as well with this. All right, so I figured it out. I had my things wrong. See how easy it is to make mistakes, guys? So what we're going to do is we're going to make it, we're going to start with a 4-carbon chain, okay? And we're going to have a methyl coming off the second, like we've done already. So you might be thinking, well, how is this any different? Okay. The difference is where we're going to have that double bond. Up until this point, guys, with the 3-methylbutene, we only move the methyl on. Well, let's move this to kind of that 2-pentene like we had before, keep the double bond in there, and this is different, okay? So, you know, it's easy to kind of get a couple of the structures, and then you might be stumped on another one. Typically, guys, on the Regents, they're going to ask you to draw one isomer, or kind of if it's multiple choice, say, hey, which of the following structures are isomers? And again, the big thing you got to remember is that they have the same number of atoms, just different structures. So count them up: 1, 2, 3, 4, 5 carbons. So this is C5. Still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's still that. So the name here then would be 2-methyl 2-butene. Okay, 2-methyl 2-butene is what it would be. So it's very similar to our 2-methylbutene, but this is 2-methyl 1-butene because, again, if they don't specify, you can assume that it's on the first one. All right, so again, practicing, but again, identification, guys. You're going to most likely have to be able to identify isomers, not necessarily draw this many. So this is just a practice piece with it. The other piece that I kind of showed you there are these things called aromatic hydrocarbons, where they're all connected. These do not follow your general formula, okay? Table Q's formula, okay? But these are super important compounds. Benzene, maybe you guys have heard of benzene. Benzene is very, very dangerous. It's a carcinogen, and back in 2006, you guys probably didn't remember this, but there were supposedly found benzene in Coca-Cola back then. Another aromatic compound maybe you've heard of is called toluene. Toluene looks very similar to benzene, but there's this alcohol group hanging off of it. That's kind of in like a lot of paint and spray paint and stuff. It gives it that sweetish kind of smell. But anyway, guys, be able to identify isomers. Remember, the big thing you got to remember is that they are same molecular formula but different structural formulas. So go ahead and take some time to really practice naming all these different types of pieces for your quiz that you'll be taking next week.